Okay, so we are on section 5. Just have an issue here with my tablet. I'm not sure what's going on. So let's see. I'll pause here for a second until I figure this out. Okay, I think I'm okay now. Just couldn't. Maybe I just didn't see it. Who knows? Okay, so I think the last problem we were on was 34. So let's look at problem 38. So a square is a rectangle with two adjacent sides equal. So you could say a rectangle. If an object is a rectangle with two adjacent sides equal, then it is a square. If an object is a rectangle with two adjacent sides equal, then the object is a rectangle. Okay, let's see what the book says. I have a different perspective. If the figure is a square, then it is a rectangle with two adjacent sides equal. Okay, I guess that's okay. If the figure is a square, then it is a rectangle with two adjacent sides equal. So I think it's the same, saying the same thing. Okay, let's look at problem number 44. Explain why the statement "a week has 8 days if and only if October has 40 days" is true. So a week has 8 days if and only if October has 40 days. Well, just from a, I guess I forgot today, if. Okay, the week has 8 days if only, well, of course, an week does not have 8 days, so this is a false statement. And October has 40 days is also a false statement. So why is that true? And so if you look at a biconditional, this is called a biconditional, if and only if. And it says that if you use this arrow in both directions, that's if and only if. That's the same as Q implies P in intersection with P implies Q. So in this particular case, we have two falses. And actually, I probably don't even need that. If you just look at the truth table for a biconditional, this, and if they're both false, then the result is true. Okay, so a biconditional is true when both component statements have the same truth value. It is false when they have a different truth value. That's on page 113. And let's see what the book says. Oh, writing exercise. Answer will vary. So that's kind of what it is. You can just look at the definition and the truth value and come up with a reason for that. Okay, let's look at, lost my cursor again here. Oh, there it is. I need a different cursor. Excuse me again. Okay, so 45 identifies a statement as false or true? Well, we just talked about this. So if both statements are true or both statements are false, the biconditional is true. So let's see if these are both true. So 9 minus 3 is equal to 6, so that's true. 8 plus 2 is 10, which is true. And since they're both true, then the rules say that the result is true. If we look at 46, and we see 3 plus 1 is not equal to 7 if and only if 8 is not equal to 8. So this is true. 3 plus 1 is not equal to 7. This one is false. 8 is, well, actually, this is, 8 does not equal 8. This is false. 8 does equal 8. Okay, so since we have differing ones, we have true and false for this conditional statement, P if and only if Q, then the result from the truth table is false. Okay, two statements can be both true about the same object. This is the next set. Two statements that can both be true about the same object are consistent. For example, it is green and it weighs 60 pounds are consistent statements. Statements that cannot both be true about the same object are called contrary. It is a Nissan or it is a Mazda are contrary. And these exercises 51 through 56 determine whether they are contrary. So, or consistent. So Barack Obama is a Democrat, Barack Obama is a Republican. So they can't be both at the same time. So this is contrary. Let's do 55. This number is a whole number. This number is irrational. That's also contrary because a whole number, an irrational number is defined as not being an integer or not. So they can't be the same thing at the same time. And actually, I think it all goes all the way to, it says 56, but I don't see why it's not all the way to 60, or at least up to 58. So let's do one that's consistent just for argument's sake. 57. This number is an integer. This same number is a rational number. So can a number be an integer and be a rational number? Well, of course it can, because a rational number is just a ratio of integers, and if q equals 1, then the numerator is just going to be an integer, and therefore it can be an integer and a rational number at the same time. So those two statements are consistent.